Welcome back to the classroom. My name is Mr. Wong. Today we'll be looking at a chemistry past paper, the 2022 HSC paper, question 36. So change that to 36 or 35 probably. Consider the equilibrium system shown. We have liquid water in equilibrium or reversible reaction with water vapor. In a laboratory at 23 degrees Celsius, a 100 milliliter sample of water is held in a beaker, and another one is in a sealed bottle. Explain the differences in evaporation for these two samples. In your answer, consider the changes in enthalpy and entropy for this process. So what we can say is our water in the beaker and the sample in the sealed bottle. The sealed bottle is what we would call a closed system. In a closed system, energy can be coming in, coming out, but mass cannot come in or out. And then for a beaker, because the beaker doesn't have a lid, we have an open system. So the mass can go in and out of the system, as we so forth say. So explain the difference. We want to show a cause and effect between the two samples. We also want to explain what changes in enthalpy there will be. Okay. So we could draw up a little table and kind of describe what's happening here, or you can do subheadings as part of the description. We'll try and do both if possible. So we will have water in beaker, and we have water in sealed bottle. And I'm going to say that we're going to have system types, and we're going to say, we'll do a different color to highlight it, just for everyone here. We have a open system, mass can escape, and here we have a closed system, mass cannot escape. Okay, so that's the system differences. If it is an open system, that means our water vapor can move towards and form more water. Our water liquid can form water vapor, and it can't really come back, because with vapor, as you know, if it's an open beaker, once we get vapor, gas will just kind of move in all separate directions, and it will try and expand across the system. So the system isn't closed, the gas will just go everywhere. So that's what we have. If it's a closed system, however, so if we try and draw, this is a very dodgy bottle, but if it's a closed system, it could evaporate into gas, okay, and then if it cools down, it can condense back into liquid water. So in that case, we have a reversible reaction, whilst the other one is most likely irreversible. So what we can say is, our next point is the reversibility. So reversibility, and we can say that it is most likely to be irreversible, and in the sealed bottle, reversible. So can say transformation, or transforms into water vapor only, whilst this one transforms into vapor and back into liquid. So that's what we have. One's reversible, one's irreversible. Okay, the next part is to then discuss the enthalpy changes. So we can talk about is it a positive value or negative value, and so on and so on. So in the situation here of our water going into, or our liquid state going to our gaseous state, remember enthalpy is about the energies you make to form the bond or to break the bond. So in the case of liquid water, remember, although they're not as tightly packed as solids, there's still some form of intermolecular bonds between them. Whereas water vapor, a gas, is very much free on its own. So we still need some energy to break the bonds or the remaining intermolecular bonds. So we could actually say the enthalpy in this case would be positive. So positive endothermic process energy absorbed to break the intermolecular bonds. Whereas on the case of the sealed bottle, we do have an endothermic and exothermic process. So the enthalpy changes can be positive and negative, given that we need, when the gas goes back into liquid, we're forming some new intermolecular bonds, and therefore energy has to be placed back, energy would be released into the surroundings. So here, positive and negative as bonds are broken and formed due to process being reversible. And last, we have entropy. Okay, so what we can say about the entropy here is entropy will increase as the vapor is less ordered and arrangement of particle becomes more chaotic, or molecules become more disordered. We'll do that. Okay. On the other hand, because this is a reversible reaction, the entropy will increase and decrease depending on which phases we're turning on. So it will increase if it goes from liquid to gas. It will decrease if it's going from gas to liquid. So that's a sort of comparison of what's happening here. Whoa. Of what we have. Okay. Oh, I don't know what happened here. Okay, just fix that up. So that's the comparisons we have here. So explain the differences in evaporation for these two processes. I've kind of gone through the two of them. I guess we can just finish off because it is saying the evaporation process. We can say in the beaker, once evaporation has occurred, there will be no condensation of the water. whilst in the sealed bottle there will be. Okay, so let's just finish that up as a sort of ending statement. So let's just put it in context. So for water in beaker, or our example there, we can say according to Le Chatelier's principle, since this is an explained question, to Le Chatelier's principle, the decrease in water vapor will drive the process to generate more water vapor, hence all liquid water will be evaporated. If we look at the water in the sealed bottle, water in bottle, process is reversible, and a dynamic equilibrium can be established. Hence, the quantity of water will remain the same in the bottle as at the start of the process. So, hence, the quantity of water, that is liquid plus vapor, remains the same. Okay, so that's what we have there. I do mean by quantity as in number of moles. We won't say volume because volume can change for the gases. So that's what we have. Okay, oops, scroll out. That's how we solve the problem here. 4 marks. Quite a interesting question. So we said explain the differences in evaporation for these two samples. In your answer, consider changes in enthalpy and entropy. We've gone through that. We've kind of drawn a little table to describe the actual process. We've looked at the enthalpy changes and the entropy changes. And from that conclusion, we can say that all the water will evaporate in our beaker example, and all the water in the sealed bottle will still remain there after a duration of time. If you found this video useful, like and subscribe, and I will see you next time.